Good morning. I welcome you all to the series of lectures on thermodynamics. Today we are going to discuss about the Carnot heat engines, problems on Carnot heat engines. Two Carnot heat engines operate so that exhaust of one is the intake of the other. See, already I told you when engines are in series, the exhaust of the first cylinder is the intake to the second cylinder. That means these two engines are arranged in series. Indirectly has given the statement. Intake of the other. The highest and lowest temperature limits are 1200 Kelvin and 400 Kelvin. That is T1 and T3 he has given. Find the intermediate temperature T2 if both engines give the same work output. That is W1 equal to W2. And second, both engines have the same thermal efficiency. Neta 1 equal to neta 2. So let us consider the first case. W1 equal to W2, what is the T2? If neta 1 equal to neta 2, what is the T2? That's it. So W1 equal to Q1 minus Q2, W2 equal to Q2 minus Q3. So let us consider the first statement. Both engines give the same work output. So W1 is equal to W2. Then W1 equal to Q1 minus Q2, W2 equal to Q2 minus Q3. These two are equal. Divide with Q2 on the both sides, left side and right side. Then Q1 by Q2 minus 1 is equal to 1 minus Q3 by Q2. Then Q1 by Q2 plus this Q3 by Q2 come to left side, so minus become plus. This minus 1 come to right side, so plus 1. Plus 1 plus 1 plus 2. Then as these are engines are Carnot engines, you can write the heat interactions, ratio of heat interactions as ratio of temperature, their respect to temperatures. Q1 by Q2 equal to T1 by T2 plus Q3 by Q2 means T3 by T2, that is equal to 2. Then T2 is common, so T1 plus T3 by T2 equal to 2. So T1 plus T3, that is T1 value 1200, T3 value 400 by T2. T2 from this you will get T2 equal to 800 Kelvin. Now efficiency neta 1 equal to neta 2, second condition. Both the engines have same thermal efficiency. Neta 1 equal to, engine is a Carnot engine, so you can write in terms of temperatures. T1 minus T2 by T1. Neta 2 equal to T2 minus T3 by T2. If the neta 1 equal to neta 2, so T1 minus T2 by T1 is equal to T2 minus T3 by T2. Then, so already T1 equal to 1200, T2 you need to calculate, T3 is 400. So from this you don't know only T2 value, so 1200 by 1200, 1 minus T2 by 1200 equal to 1 minus 400 by T2. So only T2 is unknown, you can calculate T2 equal to 692.82 Kelvin. So if both engines are having the same work output, the intermediate temperature is 800 Kelvin. If the both engines are having same efficiency, the intermediate temperature is 692.82 Kelvin. Now let us derive same equation, same problem as a derivation. A reversible engine operates between temperature limits of T1 and T. T1 is greater than T. So T1 and T1 is greater than T. Then energy rejected by this engine at the same temperature T, the energy rejected by this engine at the same temperature T, the second is T, the second heat engine rejects the heat at temperature T2. The second engine, this is the second engine, rejects the heat at temperature T2. T2 is less than T. So that means T2 is less than T. That means T is more than T2. T2 is less than T means T is more than T2. Okay. Prove that T equal to T1 plus T2 by 2. This T intermediate temperature is the average of these two. Arithmetic average of these two. T1 plus T2 by 2. If the engines produce same work output, same problem. If the engine produce same work output, W1 equal to W2. W1 is Q1 minus Q2. W2 is Q2 minus Q3. Then if you divide with Q2 on both sides, Q1 by Q2 minus 1 is equal to 1 minus Q3 by Q2. As the engines are reversible engines, this is reversible engines. So Q1 by Q2 means T1 by T. Okay, minus 1 is equal to 1 minus Q3 by Q2. Q3 by Q2 means T2 by T. Okay, minus Q3 by Q2 means corresponding temperature T2 by T. Now T1 by T plus this minus sign come to left side means plus. plus T2 by T is equal to this minus 1 come to right side, so plus 1 plus 1 2. Then this equal to, see T is common, so T1 plus T2 by T is equal to 2. Then from this you can write T equal to T1 plus T2 by 2. So the intermediate temperature is the arithmetic temperature of the two extreme temperatures. Arithmetic of the two extreme temperatures, that is T1 plus T2 by 2. If engines are having same efficiency, neta 1 equal to neta 2, prove that the intermediate temperature is the geometric mean of source and sink temperatures. If the engines are having same temperature, same efficiency, then the intermediate temperature is the geometric mean of these two temperatures. That we need to prove. Neta 1 equal to neta 2. Neta 1 is the, engines are Carnot engines, you can write in terms of temperatures. Efficiency can be recognized in terms of temperatures. So efficiency of first engine is T1 minus T by T1 is equal to efficiency of second engine is T minus T2 by T. So you can write from this T1 by T1 means 1 minus T by T1 is equal to T1 by T1 minus T2 by T. This one get cancelled. If you come to left side, it become minus. 1 plus 1, this is plus 1, this is minus 1, get cancelled. So it is 1 cancel. Then T by T, this minus get cancelled. T by T1 equal to T2 by T. So T square is equal to T1 T2. T equal to root of T1 T2. Let us prove this one. In the same equation, in the same problem, when the engines are having same work output, W1 is equal to, sorry, not this one. Yes, this one. If the engines produce same work output, the intermediate temperature T2 is the average of these two. So average of these two means, see, initial temperature is 1200, output temperature is 400. So 1200 plus 400 is 1600 by 2 is 800. So this is valid. Now, if the engines produce same efficiency, when the engine produce same efficiency, what is the formula? T equal to root of T1 T2. Now, see, T2 is 692.82. See, if you observe this one, if the intermediate temperature is root of T1 T2. If engines are having same thermal efficiency, the intermediate temperature is the geometric mean of the source and sink temperatures, root of T1 T2. So here root of the 400 into 1200 gives the 692.82 Kelvin. That is the temperature we got earlier. So when both the engines are having same work output, the intermediate temperature is arithmetic mean. If the engines are having same thermal efficiency, the intermediate temperature is geometric mean of these two temperatures. This is very, very important question. Thank you very much.